In today's video, we will be looking at the finite element analysis of a truss. The topics are as follows. First is the problem definition. Then we will look at the conventional methods to solve the problem using the strength of material approach. Then we will look at the FEA method applied to the problem. And finally, we will look at the ANSYS static structural analysis and compare the results. The problem definition is as follows. The truss member is subjected to a vertical force of 50 kilonewtons. One end has fixed support and the other end has roller support. The cross-section area and material properties are given. The objective is to find the displacement of the node and stresses in the members. We will solve the problem using the joint method to find the forces on each member and then calculate the displacement and stresses on each member. The detail of the method can be found on the given references. The deflection at node 3 will be calculated using the simple geometry and splitting the equivalent deflection into component for each truss member. By solving the equation, we obtained the horizontal and vertical component of the displacement of node 3. The slide shows the detail of how to find those deflection. FEA method is different for the truss element. The elemental matrix consists of C and S, which are calculated using the formula. The table shows the calculation of the required constant for the elemental matrix for each truss member. Then we write down the elemental matrix for each truss member. The global matrix is assembled by combining the elemental matrix, and boundary conditions are imposed, which result in a set of linear equations that can be solved for the unknown variable, and forces are calculated from the equation by substituting the variables into the equation, and stress are also calculated. We'll move to Ansys Workbench for the simulation. The first step is to drag and drop static structures into the project. Edit material properties by going into engineering data. Open Design Modeler. Change the unit as per convenience. First, draw the truss member and give it dimensions. Go to Concept, select lines from Sketches. Then choose the sketch, change the operation to add frozen. Now we will create a cross-section for the truss member. For that, go to Concept, select cross-section, choose the shape and give the dimensions as per the problem. Select the line body and apply the cross-section. Click on Generate. The geometry part is done now, and it's going to go to Ansys Mechanical. Create the mesh. Apply the boundary condition to points by inserting the fixed support, selecting the point, and applying. Add displacement, select the point, and set the x-axis as free since the node is supported by roller support. Add force in the appropriate direction and constrain the motion in the z direction. click on Solve. For the deformation, insert directional deformation. And select the point in the direction in which deformation is required. To calculate the stresses, tap on Solution tab and set the beam section result to yes. Add stress by inserting the equivalent stress and select the edge of the member. Repeat the same steps for other members of the truss. For finding the force reaction, insert a probe into that selected force reaction and add for both fixed support and displacement of roller support. Note down the value and save the project. The stress is equivalent, von Mises stress, which are used for predicting failure of the member. So for comparing the theoretical stress with analysis, we need to plot the direct stress, which only consists of tensile or compressive. Insert beam tool, evaluated the result, and click on beam tool. The result also includes sign convention, like minus sign represent a member is in compression and positive represent the member is in tension. The result is tabulated as shown. The result is matching with the analytical method with good accuracy. The stresses and force reaction are also within the error limit. Did you think of bending of truss members? And if we consider it, what would be the type of problem? And following are the references for further reading. That's all for today's video. Thank you.